In this section, we will be looking at exponents, and more specifically, positive exponents and exponent rules. Let's take a look at some vocabulary necessary when working with exponents. Exponents indicate how many times a base should be multiplied together, or in other words, exponents just indicate repeated multiplication. So in this case, we have 2 to the 4th power, and that 4 is telling us that 2 should be multiplied together 4 times. A base is the quantity that is being raised to a power, and the important word to remember here is quantity. So we want to take the entire quantity that the base is, so in this case it's 7, and if it's 7 to the 3rd, we want to multiply the base 7 together 3 times, because that exponent is telling us how many times the base should be multiplied together. Now in this instance, we want to go back to that important word of quantity, because we have the quantity of 5x, and that entire thing is being raised to the 8th power. So this tells us that the quantity of 5x should be multiplied together 8 times. Now let's look at some rules when working with exponential expressions that have like bases. And when we say like bases, we mean that the base is exactly the same. So in this case, x is the like base. So in the product rule for exponents, if you are multiplying 2 like bases together, you simply add the 2 exponents. So we have x to the m times x to the nth, and that gives us x to the m plus n. So in this example, as you see, we have 7 squared, and we know that means to multiply 7 together 2 times, and that is times by 7 to the 3rd, and we know that means 7 multiplied together 3 times. So really, we're multiplying 7 together 5 times, or it would be 7 to the 5th. Now, if we use this product rule for exponents, when we're down here looking at 7 squared times 7 to the 3rd, we know since 7 is the like base, we can add its exponents. So we get 7 to the 2 plus 3, or 7 to the 5th. Now let's look at another example where we have the like base of the quantity x plus 6 and the quantity x plus 6. So since those like bases are being multiplied together, we know that we can just add these exponents. So we get the quantity of x plus 6 raised to the 4 plus 9th power. And we end up with a result of the quantity x plus 6 to the 13th power. Now, let's look at how to divide exponential expressions that have like bases. And we'll look at the quotient rule for exponents. As you see, we have a like base of x in both the numerator and the denominator. And what the quotient rule tells us is that if those like bases are being divided, you take the exponent from the denominator and subtract it from the exponent in the numerator. So that leaves us in this case with x to the m minus n. Now if we look at this example, we have like bases of 6. And so if we write out 6 to the 5th from the numerator, that means 6 is being multiplied together 5 times. And in the denominator we have 6 squared, so 6 is being multiplied together twice. Now you notice that we have common factors here, so that can leave us with just 3 6's left on top, or in other words, 6 to the 3rd. Now if we go over here and utilize the quotient rule for exponents, we keep that like base the same, but we just subtract the exponent from the denominator from the exponent in the numerator. So the exponent in the denominator was the 2, and we subtract that from 5, which leaves us with 6 to the 3rd. Now, you want to be careful when utilizing the quotient rule because you want to make sure you're leaving the like base, and you do not want to divide through by that like base. In this case, if you divide through by 9, you're left with a 1. You keep the like base and then subtract those exponents.